All right, so I'm very happy to introduce our next speaker, Chandra Sripada from the University of Michigan. Chandra has a breadth so he's an associate professor both in philosophy and in psychiatry at Michigan, and he has an incredible breadth of activity in both philosophy and psychiatry. In psychiatry, he has done a lot of research, particularly neuroimaging work, on networks involved in externalizing pathologies, on connections between exercise and brain circuits and mental health, on addiction, on various topics in childhood psychiatry, and so forth. And he's perhaps best known in philosophy for a body of work on the nature of the will, the connection between our philosophical conception of will and voluntary agency, and our scientific understanding of the constructs of cognitive control. And today he's going to talk to us about his work from behavioral tasks to cognitive ontology.
Thank you very much, Joe. I kind of want that music. Soothing Latin sounds. It's a nice background for this topic. It frames it well. So, as I was saying to some of you last night, I actually changed up the talk, and I'm going to focus today on cognitive tasks. And this is a kind of butchering of Calvin Coolidge. It's no understatement to say that what we do in cognitive science is we give people cognitive tasks of various kinds. And this is just the A from Russ's Cognitive Atlas, and there's a lot of tasks here. And that, it really does, it's this dense all the way through. I'm going to focus on tasks in the self-regulation domain, and you'll see why in a bit. One reason is these are the tasks that I use in my own lab. So people may be familiar with the Stroop. I'll say more about that one, the go, no go, where letters are presented on the screen, and let's say it's an 8-to-1 ratio of non-X's to X's. You hit a button to every non-X, and you withhold button pressing to the X. You start to develop a kind of a habit for button pressing that you have to withhold. These other tasks, I won't go into the details, but there are tasks that tap your ability to resist a motoric response, tasks to resist a kind of spontaneous attentional tendency, a spontaneous tendency to retrieve items from memory, and on and on. There's just a lot of tasks out there. Why do cognitive scientists use tasks? It allows precise manipulation of the system. And with stimulus presentation software, this is a huge improvement to alternatives where human subjects are interacting with the participant. Research confederates are interacting with the participant, or pencil and paper kind of tasks. You really get precise control with these tasks. And this is really important. You get quantitative dependent measures such as reaction time and accuracy. It can't be stated enough how much contemporary approaches to analyzing performance on these tasks rely on repeated quantitative metrics like this. So these are some of the advantages of cognitive tasks. Tasks define careers and research programs. So my colleague John Templeton at Michigan has used systematically a bunch of different tasks. This comes from one of the meta-analyses that they did, where they have a stage theory of cognitive control that distinguishes antecedent types of control, perception stage, from response types of control at the response stage. So all of this is to say that tasks are absolutely essential to the business of cognitive science. Nobody should doubt that. They are the royal road to cognitive ontology, as Freud would say. Tentatively, I'll say a cognitive ontology is, the goal is to tell us what mental things exist and what relations they stand in. That's my working definition. All of that was true until a paper came out about a couple of months ago. At least it was on arXiv a couple of months ago. It's under review. So I don't know who's seen the paper, but I rewrote my talk to kind of be a response to this paper, because this paper should strike fear in the heart of every single cognitive scientist out there. Because this paper purports to show there is something deeply wrong with the task-based methodology that we use in cognitive science. So here's a little bit of a summary. I'm actually not going to go through a whole lot of detail of the methodology of the study. I will say a few things about it. It's incredibly elegant. It is ambitious on a scale that I haven't seen before. So there's 500 subjects here. There are 37 tasks administered to these subjects, from which 130 dependent measures are extracted. So each task can produce multiple different dependent measures. And a subset of the subjects did a repeated task battery. It's typical in cognitive science to give subjects maybe one task, recruit a new pool of subjects, get another. So this kind of study allows you to look comprehensively at a lot of tasks simultaneously. What I haven't said here, and I should have added, is they collected tons of phenotypic measures on the subjects, scale measures, self-reports of how the subjects are doing across a bunch of self-control relevant domains. Here is one bombshell, absolute bombshell from this study. These tasks, taken individually, have unacceptably low test-retest reliability. Very roughly, that's a notion of stability, and I'll say more about test-retest reliability in a second. One thing, I'll say more about test-retest reliability, but to foreshadow a bit, many psychometricians would say that these tasks are defective in a fundamental way for lacking the right kind of stability. Another thing, the second bombshell that comes out of this is the task did not predict real-world outcomes of interest in any meaningful way. So the subjects, they were asked about real-world outcomes such as their use of substances, their savings behavior, the levels of obesity and food eating habits and things like that. These tasks, which purport to measure some sort of self-control capacity, measurements from these tasks didn't meaningfully predict these. And more broadly, to the extent that there are predictive relations, they're small. And I'm not going to contest this at all. I mean, maybe one strategy would be to say that no, there actually are big relationships, but they weren't found. I'm not really going to contest this. I'm going to accept that there are small predictive relationships between tasks and outcomes of interest. I'm not going to contest that either. My main aim here today is to say a bit in response of what are the implications of these findings for cognitive ontology, and what are the responses that a defender of the task-based old regime might say? And one of the reasons I wanted to switch this up and talk about this is so I could get some feedback on this from the audience and obviously from Russ as well. Because I think this is a super, super serious matter. And you said it's under review of Nature Communications. So this is going to get widespread dissemination. People are going to talk about it. I'm very curious to know how the field will react to some of the findings here. I prefer questions along the way. So if people want to do that, please stop me and do that. Yeah.
Well, I'm just curious about using Amazon Enter for these tasks.
Yeah, I actually, I didn't want to get into the substantive questions and the methodology of the study. I think that actually these outcomes are multiply confirmed from different directions. And I don't question in any deep way the methodology of the study. I think if people had been careful and picked up the threads in the literature, these conclusions were apparent. So I think the bombshell is to systematically finally do a study that hits you over the head with the result, but it's multiply confirmed in other ways as well. Okay, so the roadmap is, I'll talk about the two bombshells separately. I'll say the challenge of reliability and the challenge of predictive validity. And the original talk on cognitive ether, if I have some time, I'll say a little bit about that, but we'll see. Okay, so the challenge of reliability. Psychometricians often insist that a measure has a test-retest reliability of 0.8 or higher. And in this study, most tasks, so the median ICC was 0.54. Look at the first quartile. It begins at negative 0.14, so that's terrible. The Stroop task in particular, Russ is open science through and through, and so we were able to get the data and take a look at it. The Stroop's test-retest was 0.12, which is terrible. and the Simon task, which is similar to this Stroop, is 0.09. So a lot of these tasks look terrible from the perspective of test-retest reliability. There's another recent study that is very influential and is getting a lot of cites, and deservedly so. It actually sets up the frame for how I want to respond to the challenge of these findings. And so this is by Hedge and colleagues, and they found that the reliability of a bunch of tasks, the best was the Posner queuing, and that's actually probably 0.56, and the reliabilities of a bunch of others were lower. There were multiple studies here in this, and so this is a summary of actually study 3. But I am emphasizing that the data is pretty clear-cut. The tasks in widespread use in cognitive science have low reliability. In order to get a sense of what are the implications of this finding for cognitive ontology, I want to differentiate two perspectives on why we do these tasks. One perspective is and here I'm drawing heavily on Hedge's way of framing the issue, which I did find quite helpful, though Hedge didn't draw connections to ontology, which is the part that I want to fill in. The experimentalist. So these are caricatures of a couple of different kinds of scientists. The experimentalist thinks these tasks are interventions. What you're doing is you're giving the subject different kinds of stimulus conditions, and you're manipulating the subject in some way. And when you manipulate the causal structure of the system, you can identify and delineate how the system is organized. Experimentalists typically are interested in the central tendencies of the system under study. For them, we are all realizations of some random variable. They want to shrink the variance of that random variable as much as possible. Ideally, you would all be clones of each other for the purposes of their research. The psychometrician is quite different. The psychometrician thinks of these tasks as measures of putative hidden constructs. The psychometrician is following Stephen's basic axiom of what measurement is, the assignment of numerals to objects and events according to a rule. You assign these numbers to people based on some sort of rule, and the next job is you've got to figure out whether the numbers are reliable, that is, they're stable, and if they're valid, that is, do they in fact measure what they purport to measure? So the psychometrician is this kind of character that looks on the outside of these tasks, tries to establish critical psychometric properties of these measures, and is not so interested in the causal structure of the system. Importantly, the psychometricians, drawn from the personality and social tradition in psychology, they're into individual differences. That's their central focus. They're after figuring out what makes people different. These two perspectives need to be understood in the respective views on what reliability is constituted in order to understand how we might respond to the bombshell that is about reliability that comes from Russell's paper. So here's the psychometrician's perspective on task reliability. So these tasks are measures. We have to show that these measures are stable and they're valid. And so this is what a reliable task looks like to the psychometrician. There's 4 people that took the task at time 1. They take it again at time 2. And very roughly, the way to think about this is knowledge of who the subject is helps you explain the variance that's seen in this data. Clearly, that holds in this type of situation. This is an unreliable task from their perspective. You've got 4 subjects here. They're taking the task, and they're flipping positions, flipping their rank order. Knowledge of who the subject is doesn't help you explain any of the variance in the data that you see over here. That kind of reliability is test-retest reliability, which I'll describe that way, reliability TR. That's the psychometrician's notion of reliability. There's a question here.
Is there any control of how the tasks are presented? Is there any standardization on how a Stroop test is done so that if it's done in China or it's done in California?
Not so much. Yeah, the issue is not the Stroop across labs so much. The issue at all Stroops, in order to be Stroops, have to have certain characteristics, but there is very wide variation in how an individual lab may perform the Stroop. But we can still say broadly that the Stroop task lacks test-retest reliability at the level that psychometrician would want. Yeah. Okay, so we got the psychometrician's perspective on task reliability. There is a link from the psychometrician's perspective of reliability of a task and ontology, and that link goes like this. A construct can be added to our cognitive ontology when measurements of it are reliable and valid. Their interest is in reliability and validity of measurements. That's what validates a construct. If tasks that purport to measure some construct are unreliable, the construct cannot be added to our cognitive ontology. So if this inferential schema is correct, and it seems like it has something going for it, then this is a problem, because when you have systematic measurement of a whole bunch of different tasks used by cognitive scientists, and you find that they fail the proper threshold of test-retest reliability, that's some bad news. Okay, so that's the psychometrician's schema, that's their challenge. Yeah.
So in both of these models, how does one think about or account for the fact that every time you probe or test the system, even in the same individual, it's not necessarily in the same state?
That's right. Any kind of contextual variation would produce some changes in a subject's performance. But the hope is that if you've got, I mean, there's lots of tasks and measures that do have, and scales that have excellent test-retest reliability. So contextual influences can alter things a bit, but the reason the psychometrician, they didn't set that standard of 0.8 because they wanted to create an impossible standard that nothing can meet. Many things meet that standard. So for example, an IQ test has outstanding test-retest reliability. So contextual variation is a factor that produces unreliable tasks as well as other things. But it is a standard that can be met by many tasks and scales. Yeah.
Well, I think that psychometricians hold the necessity of test-retest liability to adding something to a cognitive ontology. So for example, I know you know that there's been a lot of debate about IAT, which is more social psychology, but it's very psychometrician.
I'm actually going to talk about the IAT.
Yeah, okay.
Yeah.
Well, so it looks like an example of where there's, where the founders and defenders of the task realize that there's poor retest reliability, but nonetheless they want to continue to hold it in their ontology because they think it has accepted predictive validity. I mean, some people debate whether.
Yeah, I would, yeah.
On this, but this is just a conceptual point that you could get rid of the test-retest reliability, hold on to predictive validity, and hold on to it in your ontology.
Well, that's not exactly right. So a test-retest reliability sets a ceiling on predictive validity. It's impossible for predictive validity to get above, I think it's the square root of test-retest reliability. So there are interesting interconnections between these. And I'm going to talk about predictive validity as well as the IAT in a sec. So let's circle back on that. Yeah. Okay, so the psychometrician has an argument that goes like this. And I want to foreshadow and say, I don't believe this argument is correct, but I think it has a lot of grip. It looks plausible, and until you dissect and see exactly where the problems are, this is an argument that I think can be influential and falsely get people to make negative conclusions. So I'll press on. So the experimentalist's perspective. The experimentalist, as you recall, treats tasks as manipulations or interventions. And so this is what actually got the strip data from Russ's study. This is what the congruent condition looks like. This is the incongruent. This is the 25 to 75% interquartile range. So you're getting very nice separation. I mean, so I wonder how this might look to somebody who doesn't do a lot of work in cognitive science and say, oh, well, there's a lot of overlap. Actually, this is beautiful. This is beautiful separation of your variables. So this coincides about 1. That's gorgeous. So you really, this manipulation is successful from the perspective of the experimentalist. He's happy. He or she is really, really happy. And this is the difference score between congruent and incongruent. And the reason why I plotted it is to show that nearly everybody has this effect. It's not as if 10 subjects are like through the roof, and the rest of them are not showing this effect. So the experimentalist is saying, whew, this is fantastic. I've got a beautiful, reliable task, because every time I give it, I'm getting separation between incongruent and congruent. Every time I give it, my subjects are showing this separation with great reliability. We need a term for this, and this is probably the missing term in the literature. We need a term for this kind of phenomenon. When a task shows the kind of reliability that an experimentalist likes, I'm going to call that condition reliability. Conditions can be within or between subjects. I'm always referring, at least for now, to within subject conditions. I'll call that reliability C. And here's a little quick gloss. It means a task is condition reliable when we observe the effect of our condition manipulation in nearly all our subjects. Okay. So the experimentalist has a link between condition reliability and ontology as well. He says, I keep saying he, it's because I have John Janides in mind, but this obviously could be Dana Barch. So we observe a highly reliable effect. We build an explanation for this effect. So if we observe the incongruent-congruent difference, we build an explanation for this effect. Here's a kind of classic explanation. The word stimulus produces a prepotent, spontaneous tendency to read words. In the incongruent condition, you've got to override that. And so this stuff in red is part of our best explanation. Ontology consists of what we quantify over in our theories, so we include the kinds of relations in our explanation into our ontology. That seems like a very plausible inferential schema, I would hope. And so that's what the experimentalist is trying to do with these tasks. The Stroop task is interesting. So now what I'm showing here is the results of the Stroop. Again, this is from Russ's study. Here's the mean in session 1. Here's the mean in session 2. Each of these lines, so this is a subject who in session 1 was over here, in session 2 they're over there. So the experimentalist loves this task because, as you can see, every single subject is located above 0. They're all showing this effect. This mean effect is beautiful. That's one standard deviation above 0. So the experimentalist is very happy. He says, I've got a beautiful, condition reliable task going on here. The psychometrician is devastated. The psychometrician is saying, look at this guy. He's way up here, now he's down there. Look at this guy's over here. Everybody's going every which direction. So the psychometrician says, this task lacks test-retest reliability. So that's what's going on in tasks like this. So who is right? So here are the two inferential schemas. We've got the experimentalist. We observe a highly reliable effect, build an explanation. That's what we include in our ontology. He says construct can be added when measurement is reliable and valid. Tasks lack that kind of reliability. You can't add it. So who is right? It's the experimentalist that's right. The experimentalist is definitely right in this case. So that's my claim. And how to say more about that? So here's a couple of ways to bring out what's going on and what's wrong with the psychometrician's view here. This argument, it sounds plausible because we import our ordinary language notion of reliability. But this is a technical notion of reliability. This is a notion of reliability that talks about preservation of individual differences. And that's not the notion of reliability that gets you a quick argument to ontology. This notion of reliability is of the right form. I should have put reliability C there. Is of the right form to inform your ontology. Here's another way to put this point. And I worry that I'm not going to be able to be very clear here on why the experimentalist wins. So let's work on this and see if I can make this as clear as I can be. So suppose an experimenter posits the existence of a certain cognitive control mechanism based on observing reliable C effects in this truth test. What does that mean? Everybody is producing some sort of difference in the incongruent and congruent conditions. It's reliable C in the sense that it's regularly observed in every single individual. So now we have an explanandum. There is something going on here. There is a difference between the I and the C condition. We've got to explain it. We come up with an explanation that in everybody's psychology there are prepotent responses and there's an inhibitory control mechanism. So far, so good. Now the psychometrician says, hey, that task has very low reliability TR, test-retest reliability. What that means is that there is a uniform effect in all the individuals, and to the extent that there is any difference across individuals across times of testing, it's due to measurement noise. Well, that's fine. I don't change my ontology and revoke my conclusions because the effect that I'm studying is uniform across individuals. That's not a basis to change your ontology. You change your ontology when you have a basis to produce an explanation, and the explanation has kinds and relations that you produce a good explanation, and now the kinds and relations get entered into your ontology. Once you do that, finding out further that the effect was incredibly stable across individuals, such that measurement noise is the only source of individual differences, does not entitle you to, it should not cause you to revoke the initial claim at all. Okay? So another way to put it is that seeing this kind of difference justifies positing the relevant entity in the ontology. And this kind of variability, as long as all these individuals still exhibit in the central tendency the effect. Of course, every effect is measured with noise, and so there will be crossover when the only source of individual differences is noise. That doesn't matter. So that's my claim. I think that this kind of argument has a lot of plausibility. And I presently don't see the weaknesses of it. So let's, this is probably something that we should discuss further. But I do think what's going on when we look at the issue of reliability and make inferences about ontology, what's going on there is the psychometrician's notion of test-retest reliability, we're importing more into it than it actually says. Russ?
I don't know if you want to kind of talk through this now.
Yeah, well, can I do the IAT part? And then we can, maybe that's a good time to pause and see where I'm in error here. Okay. So the implicit association task is a Stroop task. Given that Stroop came out in 1920 and we have decades of experience with it and modeling approaches and an understanding of the various kinds of processes that contribute to the effect, there is so much rich literature around Stroop. I'm not clear on why more of the Stroop literature is not brought to bear in understanding the IAT. So the IAT, I'll say a little bit about it. There's different conditions in the IAT. I'm going to show the compatible condition and the incompatible condition. So there's a face that's shown, and then you've got to classify it as either, in the congruent condition, African American or bad, or European American or good. So this face would get classified over here because this individual is African American. In the incongruent condition, again, you have the classification job, but this time it's African American or good, or European American or bad, and you would classify this again as African American. Now, the reason that this task is interesting is that this condition produces a slowdown in reaction time of order of one standard deviation. So in other words, it's identical to the Stroop in how big that effect is, and that effect is massive. This is a huge slowdown for people to classify an African American face in the disjunctive category of African American or good. That creates a huge slowdown. If you are not bothered by that, and you don't see that as a problem, and you don't see that as a basis that you could have a societal set of practices that could be problematic, I don't know, intuitively it just strikes me as, whoa, that's really, really problematic. So, but I've already said that the kind of reliability that the IAT shows is condition reliability, and that is the right basis to make direct inferences about ontology. Now, the test-retest reliability of the IAT is very poor. Remember the 0.8 threshold that you're supposed to meet? That finding, and I shouldn't say it's the only finding, there are other problems putative problems with the IAT, that kind of leads to a bombshell. There's a lot of criticism of the IAT. claims that it's junk science, claims that the test is psychometrically invalid, and things like that. So if you look at quotes, one of the things to really note about it is that reliability plays a big role in the argument. So this is the journalist Jesse Singal in New York Observer. Overall, the closer you get to an R, test-retest reliability of 0, the closer the instrument is to a random number generator, rather than a remotely useful means of measuring whatever it is you're trying to measure. This is not a very good interpretation of test-retest reliability at all. It's not the case that, for example, the Stroop task is a random number generator. The Stroop task has a huge condition effect, one standard deviation. So that's troubling, because Jesse Singal definitely interacted with a lot of statisticians. I'm surprised that statisticians allowed him to say this. This one says, current studies have found the race IAT to have a test-retest reliability of 0.44. Even at the high-end range, this is unacceptable for psychology. It means the users get wildly different scores whenever they retake the test. That's false. People do not get wildly different scores when they take a Stroop task because the test-retest reliability is incredibly poor. So this is not a good interpretation of what test-retest reliability is. And we have Edouard, our colleague, saying if you have a test that's not replicated at 0.7, 0.8, you don't use it. I'm not exactly sure what he means by that, because most of the tests used in psychology do not achieve that, and that's not necessarily a problem, as I've been arguing. So there is a lot of conflation of reliability TR, test-retest reliability, which is the ordinary language notion of reliability, that is driving these arguments, I claim. In other words, they're using this argumentative schema. You add a construct when it's reliable and valid. If a measure is unreliable, you don't add it to the cognitive ontology. IAT is not reliable. Implicit biases cannot be added to our ontology. It seems like they're going through this kind of schema. And this schema is incorrect. This inference of the psychometrician, to diagnose deeper where it goes wrong, it fails in cases of extensive typicality. So if you have an effect that's uniform across a large number of individuals, this schema starts to falter. And there's an analogy here with heritability, which produces paradoxes. So heritability actually can be good evidence for innateness, but not when you're observing traits that are overwhelmingly typical. So heritability means that if a trait is heritable, then the genetics column, so these alleles, would explain a large portion of the variation here. If the environment is the source of variation, then you say that the trait is not innate, it's environmental, and that's because the environment is causing the variation in that. Most people have 5 toes on their right foot, and to the extent that there's any deviation, it's because people had, these rare farm accidents. So that just illustrates when a trait is overwhelmingly typical, you often find paradoxes that those traits have very low heritability. Similarly, tasks that have highly typical effects have low test-retest reliability. Okay, so that's a good point to pause and get some feedback on the claims there. Did you want to? Yeah.
Yeah. So I really nice analysis, and I don't disagree with the point that we should take things with a nice condition effect as telling us that there is something there. So and just to put out in the paper, we didn't say you should throw things out of the ontology altogether simply because they have low reliability. But we may have
Russ's paper did not say any of this. I just want to make that clear. It did not say any of this.
Right.
I'm actually analyzing what the response to your paper will be.
Yeah.
That's different. Yeah.
But I think this raises the question of presumably we want an ontology of the things that vary across people, right? And that is going to potentially be a different ontology from the cognitive ontology of the things that are the same across people. So the question is, what do you do with this, given that in the end you want both of those things, right?
Yeah, that's an interesting question. I'm not sure I'm willing to accept that our ontology needs to be an ontology, strictly speaking, is what exists and what relations do they stand in. And if what exists is a property that is uniformly present in everybody, enter that in our ontology. That's what ontology is for. I think what's going on there is a little bit more for the pragmatic purposes of an individual that wants to explain individual differences, which is what the psychometrician wants to do. Their practical local ontology will emphasize certain features. And inhibition as measured by the Stroop task probably shouldn't be among them, or something like that. In other words, the solution is not to claim that our ontology gets changed, but rather to qualify that some features of the ontology which are there for everybody get emphasized or de-emphasized for our local purposes. Something like that. I can see other solutions as well. I don't have a strong opinion of what to do about individual differences, although I will talk about predictive validity, which comes into that arena soon. Yeah. Okay, so I should keep going? Yeah.
Well, so, I mean, how much do you think, how much of the issue is just simply that the tasks that are being administered aren't long enough to get rid of random error due to measurement? And if they were long enough, that they would then be reliable both within and between subjects?
I'll just say in the
Yeah.
paper, we did analyses basically showing that at least for a number of the tasks, basically their reliability maxes out at well below the number of trials we have. So they basically sit there and at asymptote, which is low.
But there is a related point. Another thing that they did is they did factor analysis. So one of the things that is well known among psychometricians is if you have a couple of untest-retest reliable measures, the latent variable that you can get from them can often display substantially higher test-retest reliability. And they did show that. So that actually gets into the issue of predictive validity. So some of what I said, there are some remedies to, which is make sure you measure the same construct in multiple ways and produce a latent, and you'll probably get a reliable measure out of it. Maybe not as high as 0.8, but maybe close enough. Then this challenge kicks into gear once you do that. So that may be a good setup for the next section. Joe.
I just thought something that might be good to flag in case you don't talk about it, but I was just curious about the condition reliability.
Yes.
It seems like something that, so you're making this argument that like if the experimenter's reliability is really high, that even if the psychometrician's is really poor,
Yeah.
you have to allow it. But I think both of these things seem somewhat graded. So I can imagine a situation where now this one's just kind of a bit above the bar, and this one's just a bit below the bar, right? And so I'm curious if you'll talk about how. So question
Yeah.
one, are these in fact continuous and trading off each other?
I don't think they trade off each other. I think actually only if the experimenter's notion of reliability is directly relevant to ontology. I just don't, maybe I'm being too adamant or too in love with the distinction, but I don't think the psychometrician's notion of reliability has any direct connection to ontology, but for what Ron kind of said earlier. A untest-retest reliable task can sometimes not be useful in predicting outcomes of interest, in which case you lose the ability to validate the second dimension, that is, you lose validity, or you lose evidence for validity. You don't actually lose validity, but you lose one important source of evidence for validity. There can be other ways to validate that what you're measuring is, in fact, what you purport to be measuring is, in fact, what you are measuring. So the relations here, I would, again, put it like this. The only kind of reliability relevant for ontology is the experimenter's notion. And the connections between the psychometrician's notion are very weak and indirect and often superseded by other considerations. I don't think they trade off each other. Yeah. Okay. So now the challenge of predictive validity. When in this study, the task did not predict real-world outcomes of interest, substance use, savings behavior, obesity. To keep this at a more theoretical level, so one thing is I do have substantive kind of critiques about the real-world outcomes that were used here, and the worry of various worries about that. A common thing that we often do instead is we use task measures and validate them via self-report measures. And I'm going to kind of stick with that here. I'm going to be looking at the relation between tasks and self-report measures. And in that regard, a similar problem arises. So I'm not trying to extricate myself from a serious problem, but here is a paper that was recently out in PsycArchive, and interestingly got picked up on Vox, which I find odd for a paper that didn't go through peer review yet. But they showed that the correlation between the Stroop task, study 1, and Erickson-Flanker task, study 2, and self-report measures of self-control was small. It was, at best, it was 0.1, 0.14, something in that range. But a lot of studies have actually already shown that the relation between task measures and various kinds of scale measures, self-report scale, other report scales, clinician report, especially in healthy populations, you're looking at 0.15, 0.2, 0.25 at the best. It's a small correlation. And I now want to explore what are the implications of that. So I want to first distinguish a working ontology from a comprehensive ontology. Working ontology is what the scientist with limited time and resources actually uses in conducting research. And comprehensive ontology, the entities and relations that appear in God's inventory of the world. So God will say 0.2 correlation. I don't want that entity in my ontology. That's because he's God, or she. She's got tons of time to fill out this inventory. You and I as scientists, we have we don't want trivial effects. And so there is an argument from effect size, small effect size, to ontology. And the argument, so I just made this one up last night. I can see how this can be made precise in various ways, but I think this gets the core across. A good working ontology for a science should be restricted entities that make a reasonably large difference in the world. We don't want trivialities in the ontology. Whatever constructs are measured by self-regulation tasks don't make a reasonably large difference in the world. That's what Russ's study showed. It's what the Saunders study shows. It's what a lot of studies actually show. Whatever constructs are measured by self-regulation tasks do not belong in our working ontology. So that seems like a compelling argument. What can we say about it? How much time do I have?
About half an hour total.
Oh, okay. All right. Yeah, but people have some questions along the way. So maybe I'll run a little bit over or something like that. Okay. Because I have a little bit more to go. All right, so I want to look at this argument and see where the argument may be problematic. So I'll start by looking at that premise. So this premise says, whatever constructs are measured by self-regulation tasks do not make a reasonably large difference in the world. That's actually, it turns out that that's a problematic statement because the notion of effect size is so unsettled. And so I want to say more about that. There are two widely used metrics for effect size, Pearson's R and R squared. And I want to say a little bit about what those are. So Pearson's R is, you can think of it as when you've got two variables that are standardized, the Pearson's R is the regression coefficient. And so it can be interpreted this way. A 1 standard deviation change on the x-axis produces a 0.8 standard deviation change on the y-axis for this line, which is R equals 0.8. There's another measure called R squared, proportion of variance explained. What does that mean, proportion of variance explained? And I'm glossing over things. R squared is actually a coefficient of determination, but under Gaussian assumptions, you can just square the R and get the coefficient of determination, which is the proportion of variance explained. So one thing I want to note is that here's a very common thing that occurs in a dialectic between a scientist who's really excited and a skeptical colleague. We did a bunch of tests, we looked at a lot of variables, and I found a correlation to 0.2 between that construct I've been working on for the last 2 decades and some behavioral outcome. And the other person says, 0.2? You only explained 4% of the variance. Go home, you schmuck. You didn't do anything. And it's very, very easy to dismiss a result by converting the R to an R squared and saying, well, you explained very little of the variance. So I want to go into whether that's a legitimate thing to do and what are the rules around that. So I want to say a little bit more about what R squared is. R squared can be interpreted as reduction in uncertainty, again under Gaussian assumptions. The notion of uncertainty is information theoretic, and it turns out there's a tight correspondence between R squared and reduction in uncertainty. So it's like this: if I tell you that what the person's value is on the x-axis, here is the space of possible values on the y-axis. You've shrunk the space that you need to look at quite a bit. That's the notion of reduction of uncertainty. And R squared is giving you that kind of information. Notice with point A correlation, the shrinkage in the amount of uncertainty is quite large. But with a correlation of point 2, the amount of shrinkage in the uncertainty is quite small relative to my not knowing anything about where the person was on the x-axis. So R squared is really a measure of reduction in uncertainty. And it's important to note, just by the mathematics of it, this is clear. R squared is the square of R. But as you're marching from 0 correlation all the way to correlation of 1, the bang that you get for the buck in moving one step forward is increasing. So 0 to 0.1, you actually reduce your uncertainty very little. 0.1 to 0.2, you increase, the reduction of uncertainty is still little. But as you're moving forward, you're getting this ellipse around the line is getting tighter and tighter at an increasing rate. Okay. So this argument can be problematic because it's using this idea of a reasonably large difference, which we can operationalize or formalize as the notion of effect size. But which effect size? R or R squared? It makes a big difference because a correlation of 0.2 is 5 times bigger than uncertainty reduction of 0.04. So which of those numbers should we use? And the answer is it depends on your question. Which of those should you use? And this is a under-discussed question. You almost never get any guidelines of when you should use R or R squared. It actually took a lot of conversation with statisticians to get some insight into this. There's no good paper off the shelf that talks about this, which is weird. Suppose your question is like this. You've got here's the relation between cognitive control and impulsive behaviors. The correlation is negative 0.2. So you have the cognitive control scores for all the children in the classroom. Now you want to know what Rez's level of impulsivity is. How much better are you at predicting Rez's level of impulsivity after you look at his cognitive control score? That kind of question, you should use the R squared. That's your effect size, because you're addressing a question of the uncertainty reduction with respect to a particular position on the x-axis, and with regard to kind of personal forecasting of an individual. That's the relevant effect size here. This one's different though. So suppose, again, cognitive control is related to impulsive behaviors by that magnitude. There's an intervention that will improve children's cognitive control, 1 SD unit. You get paid $1,000 for each SD unit that children's impulsivity goes down. You know, modern incentivizing teaching campaign. How much money should you expect to make? The answer to that is you should use your R. There is no reason to use R squared. The number 0.04% variance explained has no role to play here. You're looking at the conditional mean after conditioning on the x-axis. What is the mean expectation on the y-axis? So R quantifies that number. So the bottom line is you get this effect size question is dependent on what kind of question you're asking. And so this notion of you include something in your ontology if it makes a reasonably large difference in the world, R or R squared, it makes a huge difference in which one you're talking about. So when your colleague comes to you and puts down your research program because you found an R of 0.2, saying that you only explain 4% of the variance, you say, well, I was going to intervene on children's cognitive control all along. That's the proper response. So that's one issue of this issue of predictive validity. One way to put it is if we find that these task measures are correlated with the relevant outcomes of interest, 0.2, one way to put it is, well, we've explained 1/5 of the range of what we're trying to explain. Another way to put it is we explain 4% of the variance. There isn't a uniform answer for which is the better way to describe that. I would say if I'm explaining 1/5 with some tasks, it's pretty good. That's my own reaction. Okay. Quickly, I'll say a couple of other things about this. Here's a problem with premise 1. It says the world. We only accept entities that make a reasonably large difference in the world, where the kind of implies a single world or universe of discourse. What we find again and again is that a lot of variables of interest have this kind of 1 or 2 of deciles are much more disproportionately affected on variables of interest. So this is IQ decile in 1 million Swedish individuals. This is hospital admissions for major mental illness. I'll just show that very quickly that in real-world data sets, so adolescent behavioral cognitive development study, 4,500 youth, you see this kind of J shape where the bottom decile is showing effects on externalizing behaviors that you wouldn't really see in what you might call the healthy control population over here. You see this in Russ's data set, so he's very generative for other researchers and puts his data online. You see that a measure of performance on cognitive control tasks, and this is a factor, is disproportionately affected in the bottom quartile. So this study reports reported self-control is not meaningfully associated with inhibition-related executive tasks. That's done on Amazon Mechanical Turk with healthy populations. That's completely consistent with what we see in psychiatric samples. So this is the Cohen's d effect across 3 tasks. The Cohen's d here is 0.6 for response inhibition, 0.5 and 0.64 for 2 kinds of attention tasks. Those Cohen's d are moderate, and they're actually pretty big for clinical effect sizes. So the problem with that is it says the world, but there isn't a single world here, and the effect sizes can differ substantially across subpopulations. Here's a third problem. This claim that we should restrict our ontology to entities that make a reasonably large difference in the world, that sounds like a plausible claim, but probably it's because we're thinking of single factor causation. Once we introduce multifactorial causation, so if I'm a researcher and I've got this kind of situation going on with my variables, I'm ecstatic because I'm explaining a ton of the variance in impulsive behaviors. But each one of the individual factors is not accounting for much. So what I've got here is cognitive control is reducing impulsive behaviors. But the availability of substances in your vicinity and having the urge at all, maybe the relevant urge is for nicotine, and some people have that urge and other people don't. That's explaining some variance. So is social supports. So is my own future prospects. If I'm down and out, maybe it does make sense for me to engage in certain impulsive behaviors now. This is not at all implausible, and this is an exceedingly simple model. But if we have multifactorial causation in play, then we shouldn't restrict our ontology just to things that make a reasonably large difference. We should add all the entities that make a difference. Okay, so that's basically it. I'll sum up. This paper is really, really important. Its scale, its ambition, its novel methods, and for its open science character, and for the findings that should make the field take notice and reckon with what this is telling us about our usual practice. I was saying to Russ earlier, anytime people criticize existing practices in the field, there's always some defender of the old order coming along saying, oh, things are not so bad. And that apparently is me. But I think it's useful to contextualize, to think about these findings, and I haven't said how I plan to change practice in my lab. And there are some important changes that need to be made. But I also want to make sure that we understand what are the rightful implications of these findings and what may be excessive extrapolations. With regard to reliability, I favored the experimentalist view, and I said the psychometrician's view only seems plausible because it trades on an ordinary notion. And I said that this mistake is probably going on with the IAT. And with regard to this kind of predictive validity challenge, I said there's 3 problems. Reasonably large difference The notion of effect size that you use is unclear. The world at issue can differ across populations, and multifactorial causation should make us think about this premise one and whether that premise is warranted. Okay. Yeah.
So you showed that there are tasks that have condition validity, but not necessarily have retested reliability. Can you, or predictive validity, can you imagine, have you thought of any situations where the inverse might be true, where the psychometrician would be really proud and the experimentalist would say, this isn't doing anything. There's no difference between these two conditions.
It's a
Is
good
that
question.
possible?
I don't think it is. I mean, it's possible that you could measure something. I mean, one of the issues here, yeah, that you could, if you could measure something with virtually no noise at all. So the error term is 0. There can be a trivial difference between conditions. Now, it would be statistically significant because I'm stipulating you measure things without any noise. But if you introduce the notion of meaningful effect size, and let's say that the I versus C difference were half a millisecond, that would be a trivial difference that the experimenter wouldn't care about or ought not care about. But it might very well, I mean, this is like a thought experiment almost, have exceedingly high test-retest reliability as long as there are small gradations and differences across individuals in that response. So one person is 0.5 milliseconds, another is 0.6 milliseconds, and so on. But if there's no measurement noise, it's possible for that to have perfect test-retest reliability. Yeah, so these things can, in theory, pull apart. But notice, as soon as I introduce the idea that you measure things noiselessly, this is not realistic at all. And so it looks like the experimenter's notion of reliability can be plus or minus with the psychometricians, but in most real-world contexts, the reverse is not true. That's right. Yeah.
So I understand the point about heritability from like Lewontin and others, but I didn't quite get the analogy. Could you elaborate on typicality and the role that that plays in RT reliability?
Yeah. Let me go back to that slide. Yeah, so I don't know if that analogy doesn't pop, then it's not really clear it's worthwhile to make that analogy. But it's like this. So backing up a bit, why is it that the Stroop has such extraordinarily poor test-retest reliability? And here I'll just present this as a stylized fact. It's because everybody has the same I versus C difference. So somehow we were socialized and habituated to have an identical strength prepotent response to read words, and we have an identical delay when we try to inhibit that prepotent response. So everybody is identical. Of course, I measure things with noise, and so there's a lack of stability in the individual differences on the Stroop. Okay, so that's one case. Similarly, let's take a trait that is at fixation in a population, like having 5 toes. I actually don't, I mean, this is a fanciful example. Assume that having 5 toes on your right foot is somehow at fixation in a population. Every single individual has the trait. Every single person has the genes for that trait. So I assume that the notion of gene for a trait is still coherent if there's no variation across individuals. Now, the analogous thing to measurement noise there is having a farm accident. And so there are rare individuals that, so there'll be some noise in the actual presence of the trait. And that noise will explain all the variation across individuals. So this trait will have 0 heritability. So the overall idea is that test-retest reliability is a heritability type notion. In fact, I'm pretty sure heritability is an ICC type interclass correlation. ICC is the name for how to quantify test-retest reliability. I think it's the very same form of the statistic. They're all versions of an adjusted R squared or something in that form. And so both cases that rely on variation for the relevant notion of reliability or heritability, in the absence of that kind of variation, you get funky results. Carl?
Well, mine's a more exploratory question.
Yeah.
The relationship between test-retest reliability and condition reliability, you suggested that some of these concepts are, in fact, connected. And it seems to me that if we push test-retest reliability low enough, then we might that there are conditions in which failures of test-retest reliability would show up as change difference in, you would flip the order of the condition, right? Or, and so I'm just wondering, is there any tidy way to express the relationship? The conditions under which low test-retest reliability would in fact cause you problems.
Yeah. So
You were suggesting in a way that they were independent, but they don't seem entirely independent. Right?
there are interesting and subtle connections between the two, but if test-retest reliability is very low, then it doesn't, and I have a sufficiently long number of sessions, my expectation for the condition difference doesn't change really over the long run. So there is flipping on individual sessions. Sometimes I see I greater than C, sometimes I see C greater than I, as long as the condition difference is fairly minimal. But even in conditions of very, very low test-retest reliability, my expectation is still the same. That is that I will be slightly greater than C, if that was the data generating process was like that. So ultimately I'm saying that I stick to the position that they are not tightly connected, especially over the long run, in any deeply interesting way that would make us want to connect both to our ontology. Any context, you can set up auxiliary assumptions where one would have an impact. The test-retest reliability could have an impact on what you would want to say about ontology, but there isn't a general reliable connection between the two and between test-retest reliability and ontology, is my claim.
Can I?
Yeah.
When we're doing test-retest reliability on Stroop, are we looking at the magnitude of the difference between the concordant and the disconcordant, or what is it that we're comparing test and retest?
Yeah, it's kind of over here. So I probably won't be great in saying this in words, but the way that I think of test-retest reliability is in a kind of ANOVA situation. You know, ANOVA is when you have ANOVA on your conditions, you're asking how much variance is my conditions explaining. The analogous notion of a test-retest reliability is how much variance is my subject explaining. And so in the condition case, it's actually kind of easy. If I know who is labeled placebo and who is labeled drug, do I explain a lot of variance? In the condition case, that makes a lot of intuitive sense. Similarly, if I know who's A, B, C, and D, can I explain variance in my data? Here you can. Here, no. So that's what test-retest reliability is getting at. Yeah.
Super interesting, thanks. I want to talk about the in the world part a little bit.
Yeah.
And this is, one thing is that these debates are really interesting because the predictability, is a measure of a correlation usually between two measures. And it's hidden a little bit in your, but those are two measures you might give over Amazon Turk or in a lab or something. And the in the world part is often, it seems to me when psychologists are arguing about whether something makes a difference in the world,
Yeah.
they're not actually interested in this thing and this self-report measure. They want to know, like, is this person going to have a lousy life? Is this is like this going to destroy the family life and the neighborhood, right? So they actually have a much more. They actually have an idea that this correlation, this predictive validity correlation between your construct and some kind of, say, behavioral measure or self-report measure, and then they have some idea of an additional correlation with something in the world. And then, so anyway, that didn't come out, and that seems like another thing to have on your radar. And then,
can I say something about that before you get to the second part? I agree with that somewhat, and I think Russ strongly agrees with that, which is why in that paper, the usual practice actually, from my perspective, is people try to validate that the tasks predict self-report measures, and they want a bar that's higher, and they actually collect data. It's self-report, but it's people talking about how many DWIs did I have, how much money is in my bank account and stuff like that. Those are tangible, real-world outcomes. I think it's challenging for task measures to predict variance and those kinds of outcomes. Some of the outcomes are kind of stochastic processes that a person may or may not have, even when they have a significant disposition to a certain, for example, whether I have a DWI is a rare event that represents the intersection of a bunch of different causal factors getting together. And so asking about self-reported, how many times have I gotten behind the wheel drunk? Or just more general questions of, I have difficulty controlling my emotions, seems to be a more reasonable target than very distal particular outcomes that have a huge amount of randomness around them. And there's one more point around that, and that is clinical endpoints, like clinicians' rating of externalizing or parents' rating of externalizing their kid. This is a clinical endpoint where in Russ's data set, most of these people in the bottom quartile have schizophrenia, bipolar, ADHD. They may be good types of outcomes for us to test how vigorous these correlations are. Because a lot of causal pathways funnel you into getting in the clinician's office, somebody carefully reviewing your history and assigning a diagnosis. And that may be a fair thing for people that want to defend the tests and people want to criticize the tests. At least we can agree that that's a pretty good endpoint that we can all try to predict and triangulate about how good these prediction sizes are. Okay.
Good.
Yeah.
So I didn't actually mean it as a criticism, though. You're defending the point, which is, it seems like there are these ways. So here are a couple of, in the case of IAT and in the case of another small effect, self-fulfilling prophecies in educational, where like the teacher thinks some of the students aren't so hot, and then those students end up doing worse, is the claim of the theory of the self-fulfilling prophecy.
Yeah.
And so one thing people note about in both IAT and self-fulfilling prophecies is that at the very best, these effects are very small. And then there are some responses, though, that once you take the world more robustly into account, there's a standard response, and you find it in the personality case as well, which is that that though the effect on an individual behavioral measure is small, over time the effect accumulates in ways that are profound and meaningful to our social life and so on.
That's right.
So anyway, that just seems like an important element of the way the world can participate in the relevance of these very small, potentially, right? There are models on which the world participates and makes even a very small predictability construct into something that has real bigger impacts, because very small things can add up to very big things.
Exactly.
And unless you take into account the world in this more robust sense, you won't be able to think about these other models.
Thank you for highlighting that, and that's exactly right. thinking through what to do about small effect sizes has definitely been on my mind lately, because in the ABCD data, so ABCD again is the Adolescent Brain Cognition Development Data Set, where NIAAA funded this, and it's 10,000 kids recruited and scanned on 4 occasions over the course of 10 years. So this is a huge study. It's highly, highly powered, and you're going to see a lot of small effects. And then there's a question, will it be statistically significant? So they're credible. We can believe that these small effects are real. What do we do with them? And there are a lot of positions, and I outlined several different ways in which small effects can be larger, depending on what metric you use, what subpopulation you're looking at, and so forth. One that I didn't mention that I think is incredibly important is aggregating across space, and this is the kind of Keith Payne large crowds kind of view. So even small effects in the IET can actually be highly predictively valid when you're comparing, let's say, some southern state with a history of racism with elevated IITs at the mean versus another state where IITs are much lower. And then, like you said, aggregating over time. So these are all ways in which inferences about our ontology based on small associations between variables need to be nuanced and thought about very carefully, because we may be discarding a lot of good stuff.
So we're out of time, but maybe questions after.
Sure. Yeah, thank you. Thank you.